So another thing you need to think about when running containers is that effectively you're running a mini little, I don't want to say VM, but it's a little operating system, and you're running as a user inside that container. So in this section, I know we're not talking about Kubernetes, and I'll give you a very quick sneak peek into one of my clusters. And here's where you get to slap my hand a bit, because I'm doing what this section says to not do. But it serves as a good example anyway. And in this cluster, I've got Azure Oxford, .NET Oxford, a few .NET Oxford things. Those are user groups I run. My blog, my Everstack website, and that's to do with the .NET Oxford stuff. So there's not that much in here, but if I go over to my blog and go to one of the pods, so when I say pods, well, it's not really a container, but if I actually go into that, you can see there's the container. So a pod contains containers, but this is basically Kubernetes has pulled a image down and created a container from it. What I can do here is I'm using K9S, which is a Kubernetes GUI. If I press S, it's going to get a shell into that container. Now, if you look on the left-hand side, see that word root. So that means I'm running inside this container as root, which in one way you would think is fine because a container is an isolated thing. So I'm only root for the things that are inside the container. But do remember that containers share the kernel with the host, because a container it's not like a VM where the virtual machine has its own full operating system with kernel. With a container, the kernel is shared with its host. So that means if there's an exploit that allows an attacker to exploit that, there's something called container escape, where an attacker can manage to break out from a container into the host and get root access. So ideally, we wouldn't have to worry about that. But as you'll see, it's so easy to update your Docker file to not run as root. We may as well do it. In fact, when I get time, I'm going to update all of these so they do the same. So let's exit out of that. And if I go over to our Docker file, and this is the APIs one, so let's use that as an example. Now, remember that this is the first stage in the Dockerfile build, which uses the SDK image. But it's this bit that's going to determine the final built image, the final artifact. And as it stands now, this is going to run as root inside the container. So if you remember that this is starting with the base image, we expose a couple of ports, we've got the working directory, we're copying from the other image into here. So at this point, we kind of still want root access because we're copying stuff. But here, I'm going to paste a here's one I made earlier. We can basically switch over to another user before we finish our Docker build. And what this does is, so remember that run is just running a command line tool. So in this case, this is just a bash command. So I'm saying add user. This basically says, as the comment suggests, don't interactively prompt for various information. It'll create it, and this will switch. So this basically is switching users. Just for time's sake, I'm going to temporarily comment out the tests just so we can run this. And then if we go to the Docker API and we do Docker build, what should we call it? Let's just say API 2. The file is in Docker API, Docker file, and the context is the current directory. So now if we do Docker run -it, the usual rm API 2 bash, this probably isn't going to work. No, this just run it. So because we're using entry point in our Docker file, we need to override that. And in a section soon in this course, we're going to talk about the difference between command and entry point in the Docker file. So I'll talk more about that then. But if I just do entry point bash instead, it'll have to be before API 2, I think. Then we can get a shell, and you can see on the left-hand side, this is using app user. And if I do who am I, that is app user. Going back to the Docker file, you might want to do some things like this, where basically you're changing the owner of a certain folder so that user can access or write, or there's various different chmod or change owners commands in bash. So you can customize exactly what directories that the user has access to within the container. And even that might be too much because that's write access. So again, just decide what Like, what's the least privilege that this user should have to do its job? Another thing to bear in mind is, so this kind of allowed me to bind to port 80. I'm going to be honest, I'm not sure why it did. When I've done this in production before, it's failed to bind to port 80 because normally in Linux, a standard user can't bind a port that's less than 1024. And when doing this, I've hit that exact issue. Pausing a sec, I really didn't like not knowing why that happened, why it allowed me to bind to port 80 when I was a non-root user. So I did a quick Google, and it turns out that as of this version of Docker, they've changed the default for this setting so that it's always 0+. So an unprivileged user can bind from port 0+, which explains why it worked for me locally, but also why it didn't work, and I hit the issue when deploying to production. So let's go back to the course and I'll explain how to work around this. So what I'd recommend is basically changing the port that you're listening on inside the container to 8080. Anything outside the container can still be 80, but when it goes into the container, so like the -p, when we do this kind of thing, you could still do that kind of thing. It just means that within the container, your application is binding on a port that's greater than 1024. So as you can see, let's go to that, let's go to that, let's go to that. 2 lines of code. So it's not super hard to do. And just for that extra peace of mind, that extra security, it's kind of worth adding that. And I'm certainly going to be doing that very soon to those old images you saw running in my Kubernetes cluster. I was umming and ahhing whether to make this section a full module and dig deep into how containers work, but I decided that given that you don't need to know this stuff, it's worth knowing it exists, which I'm going to show in this section, but we don't need to dig deep, and there's tons of resources online if you want to learn more about this stuff. But to use Docker day-to-day, you just don't need to know it. But as a demo though, this is Ubuntu. I wanted to use Ubuntu rather than the Windows I've normally been using because Windows uses WSL2. So there's a bit of smoke and mirrors to actually use Linux containers in Windows. But I want to show you this on a raw Linux host. So this isn't a container, this is just a Linux host, Ubuntu. If I run the following command, ps-aux, so that's a common way of listing out the processes. That's what ps does. AUX just shows extra user information and extra processes beyond the current user. I'm going to grep nginx. Now there's no results. Well, there is one result, but this is just the grep command we've just done, which has nginx in the arguments. Now I'm going to do docker run -d detached, so it runs in the background, nginx. So the nginx container is now running. If I run this again, you might be surprised to find that we've got a bunch of processes. So these are processes running, air quotes, inside the container. So if I go inside the container and do docker exec -it, the container ID bash. So I'm now inside the container. I don't think this will have PS, so I need to install it. I think it's proc ps, which is the package with PS. That's better. So if I do ps-aux, then we can see these processes inside the container. Now note that the first one starts with process ID 1, and then we've got 2930 for other processes. If we scroll up, the same list, the main one is not process 1. And you can see that they've all got different process IDs. Now, the way this works in Linux is by something called namespaces. So namespaces basically allows you to namespace different processes so you can provide isolation, or Linux can provide isolation. So for example, whilst all of these processes are in a process ID namespace for this container, and we've seen that the host can access those processes, within this container, you couldn't access other processes on the host. And so remember that the second one down is process ID 29. If we find this one here, so that's on the host, this process ID. If I exit this, so I'm back on the host. Now in Linux, everything is pretty much a file. So we can do proc, we can change directory to proc, then the process ID, and we've got a bunch of stuff here. Now, if we look at this status file, so this is just a text file, so vim status, then we've got some information about this process, including namespace process ID. And if you remember that was the process ID outside on the host. This is the process ID in the namespace in the container. So if we exit out of that, and within this directory, we can see there's an ns for namespace directory. So if we go into this, sudo ns, sorry, ls, try again, sudo ls, then we can see the different namespaces. So we've got like PID for process ID, net for network interfaces, mount for mount points, and a few others. And a container is made up of multiple namespaces to do all these different things. So we've seen PIDs, for example. So namespaces provide this kind of isolation. Another thing is called C groups. Now, if we go to a directory called sysfs, we've got a C group folder. Now, what a C group does is it allows you to manage resources like memory, CPU, so it can limit those resources, it can prioritize those resources, and that's how Docker does that for containers. If we go into memory, then there's actually a directory called Docker as well. So let's go into Docker. And we've got these hash IDs. If we do Docker PS, we can see that 5715, one of the folders matches our container. So if we cd into that, then we've got the same kind of folder structure, but this is just for this container. Let's have a look at, let's go for this one. My terminal's over here because the line's so long. If I do cat and paste that file in, then that's dumped out the contents of the file. So it's actually pretty cool the way Linux does all this and just deals with files. But look at the path. Look at there's lots of complexity around here you wouldn't expect someone just that wants to use Docker to understand. And there's another concept called union file system, which is how Docker does. Do you remember how when we talked about building Docker images and Docker files, how we said it was layered? So we had like the base container OS, then our application and whatever we want to install. So we've got these layers. That leverages Linux's union file system. But I don't know about you, but I don't want to go into these files and mess around with these files. I want Docker to do that for me. And as you've seen throughout this course, the Docker CLI is actually really easy to use. So we don't need to deep dive into this. It's useful knowing that it exists though, because some things might click. So when we're talking about, in fact, if we, let's just go back to the root. So I've got a smaller command line. If I do that ps aux grep nginx, notice how the master process is root, and this is outside the container. So things like where we're talking about security and not running your containers as root, hopefully this emphasizes more reasons why that's quite important. And also this section should hopefully show you why a container isn't really like a VM. Even though it acts and feels like one, it's really not. It's just Docker leveraging Linux's native functionality, like these C groups, namespaces, to make it look like a container is an isolated mini VM almost, but it's not.